Okay, there's a few people coming in. I'm actually going to get started because we have a lot to cover here today. Bill Baker is going to come up and join me a little bit later on to do some of the BI stuff. He's calling it the, what is it, the Willie Make It, Betty Won't show here, because we've got a lot of stuff together. What's that? Betty Don't, okay. So we've got roughly 60 slides we're going to whip through and do a few demos. Basically what I want to do is sort of tie several things together. I want to talk about the architectural vision for SQL 2005. I want to talk about some new scenarios, and I also want to connect the dots with the features. There are hundreds of features across the product, and many of them this week you can drill down and learn in depth some of the details of each of those features. And what I'd like to do here is pull some of them together in different ways, show some of the new scenarios that we're enabling with SQL 2005. So let's get going. So as I said in the agenda, we'll talk briefly about SQL 2000. For those of you who attended Andy's keynote this morning, there was a mention of BPA. We're announcing a release to manufacturing of BPA today. We'll do a brief demo of that. We'll talk about that. We'll talk about the data platform, and that is sort of our overriding architectural vision for the product. And what I'd like to do is spend a few minutes to define what we mean by data platform, and then somehow how the pieces fit together, demonstrate how they fit together for Yukon and beyond. Talk briefly about some new scenarios with SQL 2005, and then Bill will come up and drill into the business intelligence and management features and scenarios. So we've been busy. It's taken us a long time to get from SQL 2000 to SQL 2005, but there's a lot that's been happening within the product unit. These are some of the things that we have shipped over the last few years. Of note recently has been 64-bit support. We see fairly rapid uptake with that. A lot of people, large database support enabled with that. SQL Server reporting services. If you haven't had a chance to play with it, I would highly recommend it. For us within the product unit, it has changed the way that we actually run the business. Whereas we used to bring spreadsheets in and walk through all of the various things that we track, now we're doing it all online with reporting services, and it's made a huge difference to us. So if you haven't seen it or drilled in, I would encourage you to do so. So we have people out there today with SQL 2000 building very large databases. With Yukon, or SQL 2005, we'd like to blow this out of the water in terms of large database support. I'll run through a scenario with 10 terabytes, 10 years worth of data, and getting value from all of it, and how to manage it. But you can do it today. I want to just put this slide up here real briefly. Winter Corporation does a yearly survey in which they go out and they ask people about the largest databases that they have available. It was the case 3 or 4 years ago where SQL Server, Microsoft SQL Server, didn't appear on that list. Last year, and the thing I want to point out in the upper point here is that this is OLTP databases on all platforms. So any hardware, any operating system, any database software. And SQL Server is prominently displayed in this top 10 list. So at number 3, number 4, and number 9. So for those of you who are pushing the envelope and building big and interesting applications, thank you. You can actually go out and take a look at this. There's some interesting reading behind it. It's available on wintercorp.com. And so it's kind of an interesting read. I want to talk about the best practice analyzer. And for me, I've been with the product for roughly 10 years, and it's been an interesting transition. If I followed the news groups 10 years ago, it was the case that everyone who played with the product, who worked with the product as a DBA, understood much of what was happening underneath the covers. But we've made the product easy to use and expanded it such that you don't have to be a guru to use it. And I find things now in the news groups where people will come along and ask, hey, I deleted my log file. Was that a bad thing to do? And so with Best Practices Analyzer, what we want to do is capture a lot of knowledge that people have in terms of their best practices, pull it together, and provide a tool that will allow you to inspect your systems. And we'll talk about that a little bit. I was visiting customers last week, and there was one place where they're using this on internally with our consulting services on a weekly basis to go through and inspect the code that people are looking at and checking in. We have another group inside Microsoft that wants to use this tool as part of their check-in process, such that they wouldn't check in any new T-SQL code until it had been run through the Best Practices Analyzer. So again, capturing this knowledge, basically making the product easier to use, making it easier for the masses. And it's a read-only tool. It'll scan your system and provide a number of different looks in terms of doing best practices across the thing. Again, we're releasing it to manufacturing today. It's available on the web, www.microsoft.com/SQL, so you can go out there and grab it. So With that, I'd like to introduce Tom Rizzo. He'll be whipping through a number of demos today. He's going to spend 3 to 5 minutes just looking at Best Practice Analyzer.
All right, let's take a look. As Dave said, it is available today for download. We released a beta back in November of last year. And for those who have used the beta, you may see that the UI has changed a little bit, and we've added a number of features that I'll talk about between the beta and the release. First and foremost is that we tried to mimic the Microsoft Baseline Security Analyzer, so that in terms of UI, so that if you're used to that sort of user interface, moving to the Best Practices Analyzer as an additional tool wouldn't be that large of a step for you. So here I come through the UI. We can scan multiple instances of SQL Server on a single machine or across machines. And then we have this idea of best practices groups where you can come in and you can create a group of best practices. So you can say this is best practices for SQL Server 2005 readiness. This is my corporate best practices that I want to scan on particular servers. So we are very flexible in the types of groups that you can create with the Best Practices Analyzer. Now, some of you may not be able to see this in the back, but we actually support a number of different categories. So we'll check things like backup and recovery. Do you actually do backups? Have you done a backup within 30 days? Were there any failed backup events that we've seen? So that sort of thing that we will actually take and look at and report back to you whether you're compliant or not. Some other quick things is we'll find the kind of moments that you have where you do a select star inside of a view or a function. Has anyone done that?
Yeah.
Yeah, exactly. Everyone's done it, right? So we'll go out and we'll scan for that. We also scan for things like log files and data files on the same drive, using file compression, a number of different things inside of here. And then the other thing, too, is that we'll also scan for SQL Server 2005 readiness. So instead of talking about it, let's go actually and take a look at my best practice group in here. And let me bring that up here and modify it. Give it a second. And what you can see here is we have about over 70 different rules that we look for. A bunch of them are very meaty. You can go in and set properties on the rules in order to customize it. And you can see I'm scanning for a couple of rules inside of here: database disk space, file compression, file placement. If I go to my SQL Server 2005 rules, we'll scan for things like invalid user tables, some changes we've made to T-SQL between 2000 and 2005, a bunch of other things inside of here. So instead of talking about it, let me just save it off and let's actually run this. Now, a couple of things have changed between the beta and the release. The first thing that you'll be able to do is it is completely scriptable along the command line. So you can run it using agent every month, every week, every day, and find offending DBAs who are doing bad practices and maybe email them. Yeah, ooh, someone said ooh, yeah, okay, you liked it. Yeah. Use notification services, I like that even better. I have one step better for you. Something else we changed between between beta and release is now we've completely integrated in with reporting services as an optional component. So this can be an entire report, and I'll show you that in a couple of seconds once it's done scanning my SQL Server instances. So you can use the scheduling capabilities of reporting services to trigger a weekly report off of your best practices analyzer runs that you have and send it out in email, in Excel, HTML, whatever format you want to your DBA community. Oh, the gentleman up here is very happy about that. So while it's going and scanning through, I have a couple of non-compliance items in here. Just give it a couple of seconds to scan out.
So Tom has several virtual machines running on his laptop.
I'm running 2 virtual PCs on one laptop. So
talking to the SQL Server, running the native machine, and so
exactly. So you can kind of see we don't require reporting services. It is an optional thing. We have an interface inside of here where you can get the report. You can see I'm non-compliant in my database file placement. I'm running on a laptop, so my hard drive for my log files and my data files are obviously one drive. So that's nothing I can do there. But you can quickly scan through and see whether you're in partial compliance or non-compliance. Now again, we integrate in with reporting services. So this is the report manager interface of SQL Server 2000 reporting services. You see I have this BPA all reports. It's included with the tool. I can come through and you can see all my different scans. So I ran a test scan earlier this morning. You can see the one I just ran today at 1:38. And then I can come through and look at my scan details, just like we saw through the regular interface. And we'll see where I'm compliant, where I'm not compliant. So I could email this out and export it using reporting services. So really why we built this tool and we've done all this integration is really to make you a lot more productive as a database administrator and make it easier for you to find best practices where you're compliant and not compliant. So go download it, give us your feedback. We'll improve the tool over time based on that feedback.
Super. Thanks, Tom. Okay, so what I want to do now is just let's drill in and define what we mean by a data platform. And for those of us who have been with the product unit for a long time, it's the case that we came together 8 to 10 years ago to sort of build various pieces. So a bunch of folks came together and rebuilt the database server. Bill came with a bunch of folks and basically built, starting with an OLAP server. And we had a very good stack, and we have very good products within that. And we realized once we had built, say, SQL 7.0, our next step was to refine those releases. So for SQL 2000, it was refinement. And then we're at the point where Andy sort of touched on this morning in the larger context, bringing this together and actually making it better together. And what sort of value can we add for all that? So we pull this together into a data platform. And some of the pillars of the data platform and the way we define it are data lifecycle management. And so by this we mean from data birth to retirement. So most data today is born digital. So you can think about RFID, you can think about point of sale. So in terms of the data platform, we could have people out at point of sale terminals or out in the field with SQL Server for CE, collecting data, synchronizing back up. We can use DTS to transform and bring the data in as part of its birth. Now, many times when I go out and talk to customers now, the time when the data retires can be decades later. So for compliance purposes, I was speaking with a bank last week. It was 10 years of data, 7 to 10 years of data they need to keep around. Other folks doing things maybe with a pension, it's the life of the product plus several years. So it can be several decades. And the key thing is to get business value from that data the whole time while it's under management. The next thing we looked at was all forms of data. Several of us had an opportunity to talk to a CIO of a large telecom several years back. And one thing, a defining moment in that meeting, we had spent a lot of time with him. We started talking about different types of data and semi-structured data. And the CIO leaned forward in his seat and he said, the vast majority of my data by volume is in things that I don't control. So people come to a meeting with 11 different Excel spreadsheets. They're all of different versions. And I have no way of managing any of that. Someone has a quarterly budget and they drop their laptop and it's gone. I spoke last week with a financial house, 300,000 spreadsheets that they use in terms of managing the business. So relational data we're all comfortable with. Semi-structured in terms of XML. In SQL 2005, we do a great job there. Some of the work that we've done with CLR allows us to do a great job in terms of managing objects, and the mid-tier people want to program against objects. So all forms of data are encompassed in the data platform. And the next thing I want to talk about, and we'll get into this a little bit later, is programming against the moving bits. Now, in terms of business value, if you look at what web services have done for us over the last few years, they've driven latency out of processes. So whereas a purchase order process may have taken days or weeks 10 to 20 years ago, we can get that down into seconds by machines autonomously accepting and processing these things. So I think the next frontier are those processes that interact with people. So you can imagine where I might go out and create an expense report in a semi-structured format, maybe with using InfoPath, publishing it up into a system, and then have workflows result from that. So this I call programming against the moving bits, driving latencies out of processes to give business value. So our value proposition as we look at this is to have total life cycle cost, okay, be as low as possible. We've always been recognized within the SQL as having low cost of acquisition, just what you buy the product. One of the things you have to do is look at the value that's in the box, though. So we've got a very good relational database management system. We have replication of several forms built in. We have device support with SQL Server for CE. We've got ETL and a very good ETL story with SQL 2005. Incredible BI for value from your data, reporting, management, and so on. And there's no expensive add-ins. Okay? So lowest cost of development. This is something that we've focused on within SQL 2005 as well, to have the world's best tools and development tool set. And some of the things we're looking at in terms of better together, we'll give a couple of examples of that today. One of them is in debugging. So the end-to-end life cycle of developing and deploying applications. With SQL 2005, you can debug code in the mid-tier, step into code back in the database back end, step through it, and step back out again. So any of you who have ever done debugging across multiple machines and multiple debuggers will appreciate that. And it is just so cool. It'll make you so much more productive. So again, this is something that we can do as part of the integrated data platform. Pull all of that together to make your lives easier. And sort of the third tier of this is the lowest cost of deployment. integrated management. So another thing that we're working on, some of it will start to emerge with SQL 2005, are end-to-end tracing. And our vision is to have it such that you can trace a request through the front end, through the mid-tier, into the database backend, through the storage subsystem, out through the disks and back. Speaking with a customer recently who had a problem on their SAN backend where their I/O latencies went up for a reason, configuration change. It took them a long time to find that out. With the work that we're doing going forward in terms of this better together tracing, this will be very easy to analyze and find those sorts of things. And one of the things that we've done also is we led the way in terms of self-managing systems. So the work that we did with SQL 7.0 to use closed-loop feedback and control theory within the engine to make it easier for the system to heal itself, it's quite evident that others are following suit right now. And that's something we continue to push on and continue to maintain leadership on. So within SQL Server 2005, these are sort of these themes and how they come together for the integrated data platform. So here we go. This is our agenda. We've got a list of features, right? And we could stand up here and have a feature fest in terms of, and I'm sure that there are some of these would be incredibly interesting and would fill an hour just one of these little lines up here. There is a lot in the product. Okay, what I want to do over the next few minutes is to take all of these things, put them together, some of them in different ways to provide a glimpse into some new scenarios with SQL Server 2005. Again, over the course of the week, there will be a number of drill down sessions. You can go focus on some of these. So the scenarios I want to focus on for the next few minutes are enterprise data management. So this is something, how can you do what you're doing today, but doing it at a larger scale for less cost and making your lives easier? Developer productivity, we're going to focus on that. Scale out services. As we looked back 5 years ago and we were starting to figure out the product going forward and this vision going forward, we saw a lot of people building systems with what we would now call service-oriented architectures. And we built features into SQL Server 2005 to address that. I'll talk about a couple of those today. And there are many more scenarios. We could have put together dozens of new scenarios with this, but I want to focus on these because I think they really represent what we mean by the data platform moving forward. Okay? So let's talk about 10 terabytes, okay? So requirements. When I go and talk to customers, building large systems, they say, yeah, we're going to have multiple terabytes. 10 seems to be the favorite number, right? And you ask them how long it's going to take to get there. It'll be a while, but they want to manage 10 terabytes of data. They have compliance requirements, which means they need to keep the data around. Many times it's 7 to 10 years or more. And they want concurrent loading, indexing, updating, analysis, and reporting. They want to do useful things with that data. And, by the way, they want geographic redundancy. So they want another copy of this, no data loss. They want every transaction replicated at a remote site. And just to make things interesting, they want to be able to fail over in a matter of seconds. Okay? So then there's reality. Okay? So disks go up in smoke. Sometimes people really do press the wrong button. And you really do need to see what's going on under the covers. We'll talk about all this recently. So it's an interesting one about pressing the wrong button. We'll get into that. It's a scary situation. So you have a big machine, 10 terabytes of data. What you'd like is maybe having a lot of memory. So SQL Server, 64-bit. The point I want to impress upon you is when we came together and built SQL 7.0, a number of us had already ported other database systems to 64-bit. It's the case that SQL Server was running 64-bit native inside our labs in December of 1998. So it took a while to get all the pieces together and deliver them with the hardware and operating system support. But SQL Server is a mature 64-bit product. When we redesigned the system for SQL 7.0 in terms of the core RDMS, we looked at what it would take to port it, and we actually did the work as part of the SQL 7.0 conversion. So as a result, the actual porting to 64-bit was done by one person in their spare time. It's kind of a special person, but the product was 64-bit ready. And the point I want to make to you is it's 64-bit mature at this point. It runs very well. The other interesting thing about this is when I came to Microsoft 10 years ago, I often say that I left the company where a database server, the big one in the lab, was an 8-way with 13 gigabytes of RAM, which in 1994 was actually a lot of memory. I came to Microsoft and a database server was a PC, gray box on its side with a second disk drive. And it's almost that bad, but it's been neat to sort of see over the last few years that gap close, where you can go out and buy a very, very large box. And the big box we have in the lab right now is a 64-bit, 64-way machine with a terabyte of RAM. In fact, I think we only have a half a terabyte in it right now because we had to lend the other half to the Windows guys because our terabyte of RAM is still pretty expensive. But to be able to get those big boxes and run on it and scale very effectively is kind of interesting for us. So let's go look at our database. One of the features, key feature that we've done for SQL Server 2005 is data partitioning. Okay? And we can take a single database and partition it into multiple different partitions that have different storage attributes. And we'll talk about that. And we can manage them differently. So what we did is we actually looked through a number of data management scenarios, being able to take this and partition this data in what we call a sliding window of data, where the current data, the stuff I'm working on this week, this quarter, this year, is very important to me. And I want to spend a lot of money on that storage. I'll put it on the fast disks. I'll put it on the mirrored disks. Now, the stuff I get out, that's read-only, I'm just keeping around for reporting for 7 or 8 years ago, I'll put that on cheaper storage, and I'll mark it as read-only. And if one of those disks was up in smoke, I'm okay, because I can go back to tape, and I can restore it, and it may take me several hours, but I can still provide service from the database. So as long as the primary file group is available in SQL Server 2005, the database is available. So you can manage partitions behind the scenes. So we'll take a look at this one. You see the I'm sorry? So the question was, how does that affect performance across partitions? Okay. There are some optimizations we can do in terms of performance, and I/O parallelism we had already taken care of, but it's the case that if the optimizer knows, it can do the standard things, like it can do partition elimination. So if I'm going to do a query and I know that I'm querying on 1995 data in this particular example, the optimizer is smart enough to know it only needs to go to that partition to solve the query. So in this particular example, I've got the 2004 data on read-write expensive media. I've got the trailing stuff on cheaper storage. So I can exploit a cost curve in terms of storage. My current data that's important to me, put it on fast, expensive, redundant storage. The other stuff I can put on cheaper storage. So a new feature in SQL Server 2005 is something we call partial backups. So I can mark some of these file groups or partitions read-only. And then a partial backup will only back up those portions of the database that are read-write. And you can do partial full backups, which will back up all of the read-write data. Partial differential backups, which will back up only the changed portions of them. So all of this fits together to allow you to manage very, very large volumes of data and keep it online and available. So once it's there, the other thing we can do with the data platform is get value out of it. So we can run mining over the entire data set. We can run analysis services over it. We can run reporting services over it. So given the fact that the cost of spinning media has come down so much, we don't worry too much, or most people don't worry too much about tertiary storage. Just keep it on spinning media. But there's a varying degree in terms of cost of spinning media, and you can exploit that to your advantage with SQL Server 2005. So what do we want to do with this data? We want to load it, cleanse it, index a new table. So using DTS or the bulk loading packages, we can build a table, we can structure it and cleanse things in that table, we can index it, and then we can instantaneously bring that into the partition set. So for a number of data warehouse scenarios, that's a really important thing to be able to do. So we just very quickly, as we say, introduce that table as part of the partition set. Again, one of the things we thought through in this scenario. With respect to indexing, in SQL Server 2005, we can create, rebuild, reorg, drop, add or drop constraints all online. So we have online indexing support. It's fully parallel, and you can specify whether you want to create indexes online or offline. Okay? Querying and reporting with snapshot isolation. So we've introduced a new isolation level in SQL Server 2005. So we've always had the 4 ANSI SQL isolation levels: read uncommitted, read committed, repeatable read, and serializable. And we introduced a new one. And so you might have heard from someone else this consistent read, and readers don't block writers, and writers don't block readers. Well, in SQL Server, we have an isolation level that does that as well. So this will be of key use to a lot of people. So again, we get to this, I need geographic redundancy. I want another copy of the data 50 miles away, and I want it to be able to fail over very quickly. When we looked at this, we built something that we call database mirroring. Okay? In this particular configuration, what we can do is actually take the log and continuously ship it across to the other side. So there are some differences in this with respect to clustering. It's different than clustering, and there are differences between this and using remote mirroring technologies that storage vendors may provide. So there are 2 copies of the database, one that's here and one that's on the secondary mirrored site. And we're continuously replaying the log. So on a failover on a clustered system, there's one copy of the database. When the second node picks up, it has to run restart recovery. So it runs just as if you turn the power on the whole system. It has to do all of redo and all of undo. With database mirroring, we're continuously running recovery on the secondary side, such that when we pick up, what we can do is actually provide service nearly instantaneously. So that's something that if you use a storage vendor to provide this remote mirroring capability, you can't do either. Because what you'd have to do is, upon failover, actually bring up the secondary site and run recovery over there. So this can take the startup time or the failover time from minutes down to measured in seconds is what we're shooting for here. We've also added in transparent failover. So in this particular case, if my primary site goes down, the witness is the tiebreaker, such that both the primary and the secondary don't think they are the ones providing service. So the witness will detect this, actually appoint the mirrored site as the one providing service. The application simply reconnects to the same virtual name and winds up going to the secondary mirrored site. Now, if you lose the connection to the witness, the administrator can assert that the mirror should be the one to provide service. All this can happen transparently, or you can schedule it and actually fail from one to the other. Okay? So again, failover times are looking at seconds, automatic or manual failover. We can configure safety versus performance. So if you want to be safe, we'll ensure that the commit records when you commit a transaction are written on both sides before we declare the transaction is being done. If you want performance, what we can do is actually lag a little bit to give you more performance. You may be several transactions behind. Okay. Another feature that we can talk about is database snapshots. I believe we'll catch on that. On the mirrored side, what you can do is create a database snapshot. This is something you can't do with log shipping. Create a database snapshot and actually run reports or queries against that snapshot database. Again, for hardware, it works with commodity hardware, no shared storage components. It's very simple to set up. Just take a look at it. It's alter database, you appoint a mirror and a witness, and away you go. Okay. Next thing, when disks turn on you, sometimes disks go bad. In this case, our old read-only data, we actually have a problem where a disk might have gone up in smoke. The way we do this with SQL 2005 is we have online restore. So we can go back and restore the 1994 partition while the rest of the database is online and providing service. 99.9% of my queries and activities happening against the current 2004 data. Now, because we know that that partition is marked read-only and has remained read-only, when we restore it, we don't need to apply the log against it because we know there are no changes represented in the log. So the rest of the database remains online and available. In SQL Server 2005, we've even taken it so far where if you have a single page that goes bad, so we've added page checksumming in SQL 2005. If a page goes bad and turns up, you can actually get a report of that. I have a bad page. We can restore that one page online. Restore it from the backup set, run the log over it, and bring the database. So again, keeping the database online, providing service, very large databases, and you don't have to take it down to do this maintenance. Because this is a classic. Uh-oh, so I stuck this up here. So any of you have ever spent time with a toddler? This is the scariest thing a 3-year-old can say. Uh-oh. And so if only I could go back in time. I was at a conference back in the fall. It's kind of funny. They were doing this human factors studying on, in this particular case, it was database administration. And I won't mention the vendor, but they were videotaping someone mentoring a junior DBA. And this was on a large production system. And they're taping away, taping away. They had this problem. They thought they were in the test environment. They're actually in the production environment. And they dropped a key application in the app while the thing was running. And man, that was hard to see that caught on videotape. And that poor person's going to relive it over and over. But maybe many of you have had that kind of moment where it's like a split second after you press the key. It's like, oh, man, I shouldn't have done that. So with database snapshots, what we can do is create a snapshot of a database. It's instantaneous. It's read-only. And does not require a complete copy of the data. And I'll describe briefly how that works. This is underlying mechanism that we built for SQL 2005 that we use in a variety of ways. So in fact, online DBCC in SQL Server 2005 uses this mechanism under the covers. So what we do is I'm going along with my database, and just to keep things simple, let's assume there's no activity going on. It certainly can happen with activity. I create a snapshot. And at that point in time, there have been no changes in the primary database. So I create a database with a new name as a snapshot of an existing database. If I go and query that snapshot database, basically we have a map in there that says that every page in that snapshot database is really represented in the other real database. So anytime I do a query, it just vectors me through to the real database. So let's assume there's a page in there that someone writes to on the production database. Before we actually write that back to the production database, we take the existing copy of the page from the production database and write it aside. And now we update the map over here in the snapshot to say, refer to that page instead of the ones in the production database. So all of the common pages between a snapshot and the, say, production database are shared, and they're actually represented in the production database. So we can use snapshots from backups as well. So let's say I have a 1 terabyte database that updates 20 gigabytes a day. If this is Friday and I want to go back to yesterday's database, I can restore a snapshot from that point in time and only represent 20 gigabytes on disk. And so it's a very useful technology. You can use it to set up snapshots, as I said, on secondaries and the mirrored site. I can rewind a database to a snapshot to go around things that I might have done in terms of an oops. So very, very cool stuff, new scenarios from SQL 2005. So the other thing, frankly, that we learned a lot. We did a good job in SQL 7 of making the system easier to use and using some of this control theory within the system. But if I use a car analogy, one of the things we did is we took all the gauges off the dashboard as well. We kind of left a little red light there. And many times you want the gauges, okay? So we recognize that. In SQL Server 2005, if you can't get at a system that's in a bad way, that's not good. You can't get in and fix it. SQL Server 2005, we have something called the dedicated admin connection. So we actually pre-allocate resources for the system, such that you can log in if the system's in a bad state and an admin can go in and actually correct things. Also, you can see into the running system. So we've added, I think, roughly 70 what we're calling dynamic management views that let you look inside the running system. And these run from being things that you can use directly in query to find out how the system's running, down to very low level in terms of how memory is allocated and how the schedulers are running that we expect our support people to use. So, sleeping soundly and securely. Security is of interest of everyone. And we've done a very good job in SQL 2005 adding a number of new security features. So authentication enhancements. One of the things that's happened is we're used more and more in enterprise situations is people need standard security out of SQL because they're going from access from clients that may not be Windows clients. And so if you have a password policy on the domain, one of the features we've added into SQL 2005, which is a better together feature, requires Windows 2003, is we will honor the password policy. So in terms of password complexity, password history, all of those we can do right within standard security with SQL 2005. We've strengthened authentication such that by default, the initial login interaction is encrypted. And as you saw briefly this morning in Andy's keynote, we've built in encryption primitives inside SQL 2005. So what we're going to do right now is we'll have Tom come up and give a demo of that. Last thing I want to touch on is the off by default piece. So this is something that we've done in SQL 2005 where many of the new features are off by default. And the key point is it's not like we don't trust them. We've gone through and have actually done all the work to make sure that they are secure. But by default, in terms of administrator, don't have the windows open if you don't need it. So we have many of these new features. We'll talk about service broker and whatnot being off by default with SQL 2005, just to reduce the surface area. So Tom will come up and give us a demo here in terms of the new security enhancements.
All right. So this morning in Andy's keynote, you saw the Woodgrove Bank example here that showed the new encryption. So I'll just show it really quickly again, but then I'll show you how we actually built it under the covers inside of SQL Server 2005. So remember the scenario is Woodgrove Financial Services. I log in as just a standard end user, and I put in my password. And I've already run the script, so normally in the scenario they showed this morning, you would actually see the data. But since we can encrypt data based on user, as a standard end user, I probably shouldn't see financial information for my customers that I shouldn't be allowed to. So if I click on Catherine Abel here, you see I get back a bunch of binary data, and if I try and go into the credit history, I just get back the encrypted data. Now if I log out and log in as the correct person, maybe the account rep for that customer or a power user inside of here is what we're calling it, I can come in and actually see that data unencrypted because I have the right credentials in order to be able to see the unencrypted data. So if I go back to my credit history, I can see the credit card number. Now we do support cell level encryption. So in a single column, you can encrypt data based on a person. So it doesn't have to encrypt all with the same key inside of a single column. It's really, really powerful because it allows you to use different certificates inside of a single column to encrypt your data. Now let's go under the covers and take a look at how we actually built this application. So we did we did a script to insert in all the data, so you can see that all up inside of here. I won't show you all that, but there's a couple of key concepts I need to get across to you about encryption. Garish Chander's session right after this will cover encryption in more detail, so you'll want to go to that in room 2. The first thing is we have this idea of master keys inside of the database. This allows us to allow you to detach the database, reattach it to another instance, and still have all your encryption functionality work. You'll see that we support not only password-based encryption. You can use a password instead of certificates and keys. We completely support that, but the number one call to a help desk is what? Password reset, when people forget their passwords. So we added the extra layer, which is the ability to support certificates. So the first thing you're seeing here is I'm going to create a certificate for the power user account that has permissions on my database. And then off of that certificate, I'm going to create the key inside of the database here. And you're seeing a couple of things in here. First thing is we use, for those who are cryptography people, we use symmetric keys to encrypt and decrypt the data inside of the database. And we support all the different algorithms that the Windows Crypto API supports. So here I'm using triple DES. You could use AES. You could plug in your own cryptographic provider. And then you just see here I'm encrypting that then by my certificate. So we are very flexible in the sorts of key management and certificates that we support inside of SQL Server 2005. Now let's go and actually use this stuff. So the first thing that I do is I open up my symmetric key using that certificate. I update my customer, and what I do is I take my client's social security number. You'll see this new intrinsic T-SQL functionality, which is encrypt by key and decrypt by key. So what I do is I say encrypt by a key. I pass in my key GUID for the power user key. And then I just go in and update a whole bunch of other things in here using that encrypt by key functionality. I close out my symmetric keys and I revert back my authentication. And this is how easy it is to use the new built-in encryption functionality. We took a look and we said, well, how long would it take a customer to build all this infrastructure that we built into SQL Server 2005? And we assumed it would take easily 2 months using the crypto API and using a whole bunch of custom user-defined functions, CLR procedures to build what we have in the baseline system. Now, encryption is not a panacea, right? It's not going to solve world hunger. It's not going to make your system entirely secure. You still have to follow the other best security practices, but this gives you another tool in your arsenal in order to make your systems more secure if you use it correctly.
Super. Great. Thanks, Tom. Okay, so let's focus on developer productivity here for a few minutes. And again, a number of key new features in SQL Server 2005. We'll just touch on some of them here. So CLR integration, a lot of people know about that. I want to sort of define what we've done there and basically present that. Database projects, as I said, being able to create databases, deploy them, integrated debugging we talked about a little bit earlier. Native XML storage, there are several talks later on that drill into that. T-SQL enhancements, we'll touch on those very briefly. Talk about service broker and query notifications. So with respect to the CLR integration, a couple of very key things here. Others have said, well, other vendors have embedded a Java VM, how is this different? We actually spent a lot of time building a hosting layer within this. CLR is deeply integrated within the system. So the hosting layer that we've built coordinates between the CLR, the runtime, and the core system. So coordination between threads, memory, garbage collection, all of that's done through the hosting layer. There are a number of dynamic management views that will let you look inside the runtime to find out what's happening there. So the CLR, a lot of people believe that we said we're going to throw out T-SQL and you can rewrite things in C#. That's not the case. This is embedded technology that you can use in a number of different ways. So you can use it to extend the system. Okay? Scalar functions. Now T-SQL is relatively complete, but it's a lot easier to write something and a lot more performant to write it in a CLR-supported language. We'll demo that in a few minutes. Table-valued functions. You can do them in T-SQL or within CLR languages. Ability to add your own types. User-defined aggregates. It's been the case that every release someone says, why don't you do my funny moving average for this or that? By implementing against a particular interface, you can build that yourself now, your own aggregates. And procedures. You can just write procedures that could replace extended store procedures or procedures that do data access. And this was what people think of when they refer to rewriting store procedures inside the language with the CLR-supported language. So again, all of these things you can use it for. Data access is just one part of it. Okay? And there's a talk coming up, .NET framework-based programming that you can go look at. It's DAT 318. They'll drill into a lot of these different usages. Again, key things, 2 key takeaways in this slide. One, it's very deeply integrated. It's not just something we throw in there. You can look at it and manage it within the system, and you can use it to extend the system. It's not just about replacing T-SQL. Okay, Visual Studio integration. So SQL Server 2005 based projects, making it easier for a database developer to go out, develop and deploy applications. Talked about integrating debugging from the mid-tier to the back end. That's very cool. So in the end, this is about increased productivity, letting you develop your applications faster and deploy them faster using the services of SQL Server 2005 and Visual Studio. So native XML storage. This is another one that we'll just touch on here. I'll sort of describe overall, we looked at doing XML inside the database maybe 3 to 4 years ago. And the story I tell is that we had a bunch of people come over from the Exchange team, and there's a continuum where on one end of the continuum you've got native XML storage, an XML database. On the other end of the continuum, you've got the gray-haired relational folks who said that we remember object databases, this is just a passing fad. Now, there's lunacy at both ends of the continuum, and we had it represented. We have all bases covered in this discussion. In the end, what we did is we built a new data type. You can just create a column of type XML within SQL Server 2005. So if you have an application that is 99% relational and you want some XML open content, you can go off and do that. Order entry system that has some XML for some annotations, you can do that. If you want to go off and build a document management system, it's principally XML content, but I want to have a couple of scalar columns to maybe represent a document ID and an owner, you can go out and do that. Very flexible, fully indexed schema support. So you can have a schema collection bound to that column. Anything that gets stored in there has to be compliant with one of those schemas in the schema set. Again, very cool. Several sessions this week you can drill into. T-SQL enhancements. So a lot of people ask, well, what have we done with T-SQL? We continue to invest in T-SQL. There are a lot of new things within SQL Server 2005. Varchar max, var binary max was the case where we had text and image. It was a completely separate programming model. What we've done is unified that. So a lot of the intrinsics that didn't work over text and image work over varchar max, var binary max. So you can just declare columns of this type. We have a full programming model where you can replace portions of large strings. You can run substrings. You can run all of the intrinsic string functions over these. Exception handling within T-SQL. So you can catch failures and actually handle them within the code. So this is a huge advance in terms of T-SQL. Recursive queries, people have asked for that. That's in the system, done with the ANSI syntax. Multiple active result sets, something that we've done in here. So people coming from other environments where they're used to having result sets, running through one and querying off of that based on another, that's in there. Pivots, unpivots. I don't even have time to show that. Others can talk about that this week. Top, you can pass in an expression. So takeaway on this is we continue to invest in T-SQL. We continue to enhance it. It is it's the way to get at data within the server. A lot of new stuff for the T-SQL programmers. Service-oriented database architecture. We talked about service orientation, how people were building large-scale apps several years ago. And we built a number of features into SQL Server 2005 to address that. One is web services access directly into SQL Server. So we don't expect people to take their SQL Server, open things up as web services and stick it out on the internet. For people who are replumbing things in terms of web services, the ability to take a SQL Server with some stored procedures, mark them as web services, and access them from other clients or other components in their service-based architecture will be very key. And it's very simple to do with SQL Server 2005. The service broker, which I'll actually spend a few slides on here in a minute, allows you to do a number of new types of applications. It's a decoupled and distributed application development environment. Query notifications. So we looked at people who were building caches. We said, what can we do within the system to actually help improve the fidelity of those caches? Query notifications. So again, all of these new things to help in building out service-based architectures. We'll talk about them. So web services, this is using http.sys, the new kernel mode listener. No client dependencies. We have a new HTTP endpoint that you go off and create. You can configure it and then expose functions and store procedures through that interface. Fully secured. If you want, you can expose SQL batches, so you can just have ad hoc SQL coming in through this. Again, that's off by default. And this is very simple to set up. And for service-based architectures where you want to have a data service providing access, it's a very simple thing to get up and running. Service Broker. So Service Broker is an asynchronous distributed programming environment, which is kind of interesting in the fact that people don't quite understand it when they first see it. There's a talk this week that goes through this in great detail. This allows all sorts of new scenarios. So fully integrated with the database engine. We'll talk about how it's different. The programming model is all in SQL, or DDL and DML. So you go off and you create services and queues and message types. It's dependent, or there are several SQL Server 2005 features that are dependent upon it. Events, query notifications are delivered through Service Broker, and we rewrote SQL Mail and SQL iMail in SQL Server 2005 using Service Broker. So inside the engine, we can enqueue mail messages. Okay? Then the actual mailer process runs outside of the engine as a separate process. So you don't have to run MAPI in with the database server. This is all those people who haven't been understanding, that's very cool. It is all fully transactional. So even if that mailer process got stuck, you could whack it and bring it back up again and not lose any work. So very cool scenarios, we'll talk about them. Asynchronous store procedures you can implement with this. Scalable, distributed, either single database or multi-database applications. So here's a traditional synchronous programming model. We have a client application that goes in, invokes a store procedure, all within a single transaction. With the Service Broker, what you can do is actually split this up. So a client application goes in and enqueues a piece of work. Okay? This is persisted inside the system in one transaction. So it's completely transactional. As soon as I'm done, I can let it go, and I know that it's safely stored there as a unit of work ready to be operated on. Then from there, I can pick something up off of that and actually launch a store procedure. So I can actually bind store procedures internally. So we have what we call internal activation. So there are store procedures you can bind just waiting for a piece of work to become available there. This runs in a separate transaction. Or, in the case of SQL iMail, we can actually run one or more worker processes outside of the server doing the same thing, pulling work off of these things. All of it is transacted. And then the third thing we can do with this is to actually go and, I'll show it here in the next one, run this across SQL instances. So again, client app comes in a transaction, submits a piece of work. Another thing, we can take that piece of work, reliably get it over to another SQL Server instance, and then have something come up and pick it up from there and actually operate on it. So if you go back, that thing that went from one instance to another, it said transaction around it. Really that means we can get it there reliable. It doesn't use two-phase commit. It uses standard reliable messaging technologies, like retries, duplicate elimination, and such. So we'll get it over there, and you can actually have work results. So you can imagine building out some large-scale applications this way. And again, you can use it within a single box just to decouple things. They're decoupled in transaction, they're decoupled in time, and they're decoupled in terms of security context. So some very cool things you can do with this. Okay. Query notifications. We'll run into this real quickly. So the ability to subscribe to the results of a SQL query. So in SQL Server 2000, we built something called indexed views. In indexed views, I can create a view and then actually persist it. And there are two main pieces of technology inside the query processor to pull that off. One is, if I make a change to a row in a base table, knowing which indexed views I need to maintain as a result of that change. And then the second thing is the matching, to know that as a query comes in, where can it be matched, or how could I exploit some of the indexed views to use it? So for query notifications, what we did is we took the first part of that, the second part of that, knowing the matching. So, the update logic. So we can actually submit a query into SQL Server rather than persisting the results. That can represent a query that we want to be notified on. If any other transaction comes in, makes a change that affects the results of that query, we can then go off and notify. And we can use this for building multi-tier caches that are very responsive. You don't have to worry about timeouts or periodic refresh. Don't call us, we'll call you. So here's an example of this used where I can have a request coming in that actually represents a query subscription. Inside the query processor, if anything changes that would change the results or the result that went back here, we can enqueue something into the Service Broker, dispatch it out such that I can invalidate caches. So in ASP.NET, this is wired in. So if I have a data-dependent page, an example I could use is if I have the top 10, if I'm selling books and I've got my top 10 list of books that are selling, I don't have to poll every minute to see if something's displaced number 10 or number 9. What I can do is actually have a query out there. If something does change that list, I'll get notified and then I can go back and just issue that query once. So very responsive caches, base building block. We've integrated it in ourselves. You can use it to build your own responsive caches. So Let's talk real quickly about the developer enhancements.
Yeah, my mic on?
Yeah.
No, my mic isn't on. All right. Well, I'll just shout. Oh, there we go. We are rushing through a bunch of things here. We do have hands-on labs that go through all this stuff, so I would recommend you go and try it. What I'm going to show you here is we're going to have a little shootout between T-SQL and the SQL CLR. And this is one-sided a little bit in that the SQL CLR is probably going to win this one because it's more complex string manipulation that T-SQL doesn't handle as well as the built-in .NET Framework technologies. But you could also do the flip side where there's things that you'll want to do in T-SQL rather than doing in the SQL CLR, things like core data access, because that's what T-SQL is really built for. So we are publishing a white paper on best practices of when to use T-SQL and when to use a managed store procedure or managed user-defined function and those sorts of things. That's a question that we always get asked by customers is, when do I use which? You gave me a bunch of choices here. Tell me when to use whichever one, and we are doing that. So what we're going to do here is I've written just a really quick C# user-defined function. As Dave said, we are completely integrated with Visual Studio 2005, so if I just come in, right-click, add, and add a new item, you'll see directly I have new templates for store procedures, user-defined functions, user-defined aggregates, even user-defined types. Now, I've already written a whole bunch of the code. I won't try and type it all up here with my little fat fingers, but you see here we're using the new in-proc data access provider. So we don't have to use SQL client. We just use in-memory access to SQL Server because we're running in the same process as the SQL Server system. And then I have a bunch of attributes in here to tell it I'm a SQL function. You can do some optimization. I can tell it whether I need read-write data access, read-only, or no data access at all to kind of tweak the performance. And what we're going to do is we're going to go and do some string manipulation. So I'm just going to reach into a string and pull out whatever element you tell me of a zero-based array. So element number 5 in the string, I'll just walk, we're semicolon delimited, walk to that element, pull it back out, either the element or the actual length of that element. So this is the C# version of this. Let's go back to the T-SQL. Remember, we've got one line of code here, list.split, and then return back the element from the array that's returned from the split function. Pretty simple to write.
I could probably write that, Tom.
You probably could. Maybe.
Yeah.
You could probably write the T-SQL part.
Yeah.
So I've got a database of about 19,000 rows, right? And so what I've done here is I've created another function. Let's see, my T-SQL function. Let's scroll up. You can just see here I create another one in T-SQL. It's a bit longer, a bit more complex, right? It's not a simple line inside of here. And we'll see how well it performs. Who wants to bet on T-SQL? Anyone? No bettors.
No takers.
All right. So what I'm going to do here is I'm just going to run these two, and I'm going to collect the statistics on how long they took to execute. So let's just start this up. Let me scroll this up here. The first one's going to be our CLR function. While it's running, we can see the query still executing. If I just flip over, CLR already came back in 1,846 milliseconds. We'll let T-SQL continue to run while I step you through how we got the actual information inside of the database using our user-defined function assembly. Because T-SQL does take a good minute and a half to come back inside of this function. So you can see a scenario where SQL CLR makes a better choice in order to do functionality inside of SQL Server 2005. So the first thing is I created that user-defined function inside of SQL CLR. And then what I do is I just use some new DDL that we have that says create an assembly. I name my assembly. I pass it the path to my DLL that I've created using the CLR. And then all I do down here is I just say create a new function. It looks like just a regular function to SQL Server, whether it's written in T-SQL or the CLR. I tell it what my parameters are. I put in what I want to return back. And then I just say external name SQL, whatever I name that assembly up inside of there, the actual function I want to call inside of that assembly. And that's pretty much it, right? And here's my two functions for member length and actually getting the member themselves. I'm trying to fill for T-SQL as best as I can here, right? There we go. T-SQL came back in 89,450 milliseconds.
All right.
So you can see some SQL CLR performance inside of there.
So I sent this off to Tom as hey, can we do a demo like this? And yesterday afternoon he says, I said, how much faster is it? He says, it's 3 times faster. I go, are you kidding me? I figured it'd be much, much faster. And so he dropped to 0. So how many?
Yeah, I dropped to 0. It's about, I believe, 40 to 45 times faster between the CLR and T-SQL.
So, again, extending the system. It looks just like a function. It's the right tool for that particular job. It's all integrated. You can do a bunch of cool new stuff with it. So with that, what I'm going to do is turn it over to Bill Baker to come up and talk to you about some of the BI improvements in SQL Server 2005. Thanks, Bill.
Okay, thank you, Dave. Good afternoon. I'm happy to have a few minutes to spend with you on some of the BI components. These are the BI components here. It's the same picture that Dave showed you before, just collapsed down to the things that specifically speak to BI. And what I'm going to do is we're going to turn this whistle-stop tour into kind of a whirlwind tour. I'm going to give you a couple of highlights on each of these. I'm going to share with you a kind of new idea, or maybe a new idea for some of you. I'd love to hear from you. I'm going to be in the cabana for 2 hours or an hour and a half after this if you want to discuss this little new idea that I want to mention to you. I'd be happy to do that. We do have talks about all of these things still coming up. Ariel Nets will be talking about analysis services at least once, I think maybe twice. Brian Welker has at least 2 more presentations on reporting services. Mahesh is going to be speaking about the management tools. And Mike Blazak will be speaking about DTS, and you're going to see the development tools through all of those presentations. Each of these speakers will use those tools. So one of the very, very key components in BI is the relational engine. A ton of stuff in the data warehousing and BI space is done relationally in normal forms. And these things that you see listed on the left here, Dave mentioned all of these, but he mentioned them in the context of data management, of DBA productivity, of developer productivity, and sort of ease of development. But a lot of these play a great role in data warehousing too. Partitioning is probably one of the more obvious ones, where you have older partitions that you just want to keep in read-only form. They're not going to change very much. Oh, that's a good thing to have. Now I just got to figure out what F and R means. Probably forward and reverse, right? Online operations, so when you're doing batch loading, that you don't degrade the performance of the machine. 2 that are really interesting to look at are the bottom 2. The native XML and the .NET framework turn out to be really important in these kinds of scenarios, because as we want to get more and more value from more and more data that's been stored in those operational systems, we're starting to reach out to things that aren't strictly table-oriented or relationally oriented. We had a great presentation this morning on using reporting services in front of Exchange. That's hierarchical data. So we're starting to get value and knowledge and information out of other data sources. The XML data type helps us model those types of things in the relational environment and then pass them through to cubes and reports and things like that. The .NET framework's important too, because increasingly we get a lot of value out of closing the loop, right? BI is important because we can share for a lot of reasons, but one of them is we can share best practices. And we can't share best practices if the decisions that people make using our data and our tools don't somehow get reflected back into the operations. We call that closing the loop. And the .NET framework, the CLR languages and programming, and the ability to do web services and reach out and talk to those operational systems becomes really key for those kind of scenarios. So, building from the bottom up. Data transformation services. This is a complete overhaul. It is so different that we will have the old data pump. If you're used to DTS as it exists in 2000 now, that will be in the box. You won't have to change a thing. We will run existing packages in the existing tools. But we have a new architecture, pipeline-oriented. We do not any longer pick up the data, put it in disk, pick it up, put it in disk, pick it up. We keep it in memory. And we're actually very, very smart about that. We look at the entire transform, the package that you're going to run, and we plan ahead and we say, this thing's going to split. So maybe we'll make a copy here while we have our hands on the data. And then it's going to merge here, and we're going to do some deletions, so we'll have a way to mark those deletions. So if you think about it, it's almost like a query optimizer doing a plan, looking at a pattern of work and saying, how can I do that most efficiently? We are over 2 orders of magnitude faster than DTS and SQL 2K. Okay, so if you've ever struggled with performance and trying to get your DTS packages in the batch windows, we've done a lot there to help, and I hope you find that true when you start to play with Beta 2 in just 2 months or less. There's a lot of built-in data warehousing and BI savvy in all of these components. So things that you do all the time, like slowly changing dimension management or surrogate key generation, if you're doing those kinds of things, we've put that kind of knowledge into DTS, into analysis services. And those 2 things work together to implement things like slowly changing dimensions. So you don't have to do the programming that you used to have to do those kinds of things. Plus, we've done a whole new visual programming and debugging environment. So you can actually watch the rows go through your DTS package. You can set breakpoints. You can look at the code you're running in your transforms. You look at data before and after your transform. So really going after the productivity of building up those ETL packages. In terms of analysis services, if you're into analysis services, I encourage you to go see Ariel Netz's talk on real-time BI. There's two very significant things that I'll highlight here. One is the unified dimensional model. We are trying to pull together the traditional hierarchical view that OLAP brings to the table with the attributes-based view that we traditionally have in relational type reporting. Those two worlds have not mixed very well, and in effect we've made users kind of decide how they want to navigate their data. The UDM is like a cube with a lot of metadata enhancements. It's a cube on steroids. There are places in there to express more and more business logic than we ever had before, but also the ability to look at your data from either perspective, either by navigating, drill down, expand collapse type hierarchical navigation, or attribute-based navigation, where you say, I see all the blue shirts or all the extra larges or whatever. The other piece that works in conjunction with this is called proactive caching. One of the things that's always been true about OLAP, and I've been in the OLAP business, I've been in the BI business for a long time. This is the second big OLAP server I've worked on in my career. OLAP has always been this different thing. It's interesting, it's useful, it has all these great properties, it makes things faster, it's easier to express queries. Navigation and query become the same. That's one of the beauties of OLAP, right? But it's always been this different thing. I had to have a guru about it. I had to build the cube. Sunday night I had to build the cube, and then I had to build the cube every day, and while the cube was getting bigger and my batch windows were getting smaller, it's managed differently, and it has a different management UI and different security model and all that kind of stuff. Proactive caching is how we're going to pull these two worlds together. So when you think about what a cube is, it's really just a storage optimization. In its physical manifestation, it's really just some pre-aggregates that we've done in a clever way, put on the disk, and we can go bang on that disk really fast, get those aggregates, and not have to go back to the relational database. But we made the second store with all the attendant problems of the second store. In proactive caching, we do that transparently. So when you deploy a cube to a cube server, it will instantaneously be able to respond to queries. It'll have to go to Relational Engine. It has had no time to pre-aggregate or do anything like that. It will go to Relational Engine. It will not be as fast as if it had the time and had already done those aggregates and put them on disk. But in the background, it will start building that aggregate cache. So you can treat it transparently. If you lost that machine, for instance, it could just all start again. You could deploy that cube to another server and just let it start accumulating aggregates in the background. Now, Dave talked about the query notifications. We use that mechanism. So when the underlying source data changes, we can drop the cache. We can drop it instantly, or we can have some latency in there. If your data only changes once a week, you don't want to be dropping your cache until, well, you only get that message once a week. But you may say things like, I don't really need every last transaction. I'm willing to have data that's 4 hours old. So we'll just sit there and not drop the cache for 4 hours, but then when 4 hours expires, we'll drop the cache, start to rebuild it. So you can control the latency of the data in there. Again, a lot of knowledge of BI built in. There's a KPI editor and a set of metadata that clients and the server can transact to get really rich both descriptions and display of KPIs. We've done a lot in data mining. We've added 6 new algorithms to the 2 we had, and the team says we're ready to add 2 text mining algorithms. I haven't seen the test plan yet, but I think we're going to have 2 text mining algorithms added to SQL Server 2005 as well. Everything in SQL Server 2005, all the programming interfaces are web services. So if you've used XML for A, that becomes the native protocol. And then the COM interface becomes the shim. So you'll get much better performance on web services access to analysis services. Things have been going pretty well for us. The chart is a little easier than the table. The point of this slide is we're in this for the long run. We were not in this business at all 7 years ago. This is our 3rd release, and we're just going to keep doing more and more and more. And we're very gratified by the success of the product. We very much appreciate your use and adoption of our tools, and we very much appreciate the feedback you give us, just in real time in the news groups, but also at events like this, like at PDC or here at TechEd. We really do appreciate the feedback. That's what motivates us, and that's what drives a lot of change in a product. So never be shy. My email address was on the screen before. It's Bill Back, B-I-L-L-B-A-K. Anytime, send me email. I do read all my email, and I respond to most of it. And don't send mail to B Baker, because he's really tired of sending me forwarding me emails. Reporting services is new. How many people have had a chance to look at reporting services? That's a good, healthy number. That's also very gratifying. This is something we released this year as a component of SQL Server 2000. We're turning the crank again. There's a lot of new features in SQL Server 2005. One of them that we're really, really interested in, there's a whole bunch of stuff on momentum. If you get the slides later, you can read this. This is a little bit of, bragging, I guess. The thing I want to talk about is we just did an acquisition in April timeframe of a very small company called ActiveViews. We continue to invest in this product. Don't think that this is just a little flash in the pan for us. We are really, really serious about reporting, and we're going to invest in this release after release after release. And what we're doing with this new ActiveViews technology is enabling ad hoc reporting for end users. You may already realize that our tool today for building a report is Visual Studio. And a lot of people really love that. If you've been building these nested loops calling ADO to build reports, when you see what we have in Visual Studio, people walk in and go, I need that. Not how much, not how does it compare, but I need that, because it is such a more productive way to build a report than coding it the old-fashioned way. But end users don't have that reaction. We're going to address the end user market when we get to SQL Server 2005. This feature will not be in Beta 2. It will not, but it will be, hopefully it will be in Beta 3, and it absolutely will be in the RTM release when we go to manufacturing next year. The key thing here is that end users get an infinite ability to drill through. We have a semantic model under the database. Anybody here ever use English query? I mean, there should really only be about 4 hands by my numbers. That's actually quite a bit more than 4 hands. If you've ever used English query, you realize we have a very, very rich semantic model of a database when we've modeled it with English query. We have an even richer semantic model now. And we use that model to take a user action. You can click on any number in a report. We'll look at that number and say, where did it come from? What is the semantic of that number? And use that semantic database to build a new query and a new report. And so you can infinitely drill down, just chain to chain to chain to chain. And nobody has to pre-author that stuff. That's a really fabulous feature. But we go a little bit beyond that. We allow end users with permission to modify reports and even create reports if they want to. So we're really rounding out the package, continuing our investment in this tool. And then lastly, the development environment. We are betting huge on Visual Studio. You already saw a demonstration of doing some T-SQL and doing some CLR work, integrating the development and the database experience together. All of our editors, the DTS package editor, the cube editor, dimension editor, KPI editor, report editor, all those things are in their components. We use the VSIP interfaces. They are integrated into Visual Studio. If the user, if the person who's going to develop this app doesn't have Visual Studio, we will lay down the basic shell of Visual Studio. But if that person does have Visual Studio, then we will pour our bits in. So if you're building a complete end-to-end app, you've got all the parts, all the BI objects, but also all the code, the web pages, all the pieces of an application in one integrated end-to-end environment. There has never before, I don't think, been a professional-grade end-to-end environment for data warehousing and BI professionals, and that's what we're hoping to bring to market with this. And then I think we're going to go, I want to share my little quick, we have like 7 minutes, so this is rapid. Are we going to do a demo?
Sure.
Okay, we're going to do a demo too, so this is like the high wire act. So here's my little idea that I want to share for a few minutes, and I'd love to chat about this in the cabana. The traditional use of BI is as a feature of an application that allows the end user of that application to make a better decision. You know, and if they're a salesperson or using a CRM app and it's showing them which customer is the most likely to buy or who they should call first or prioritize the work, that's using BI to make a better decision. There's another way to use BI, and that's to make a better application. So one example of this would be your application has logs. It produces logs about its operation, things that have been going on. You can do analysis on those logs. Why wouldn't you think about using something like data mining or the forecasting that we're bringing out in SQL 2005 to say, hey, you know what? You're going to run out of disk in weeks. Or you only have room for so many customers. Or you haven't touched something in certain amounts of time. So that's a very rich use of BI in a non-traditional way. Think about data validation. Look at this little data validation screen here. So we've got a couple things, gender, age. We have age of 25 and we have education. Years of education is 25. That's probably not correct. And the truth is we could write a rule that said if those two numbers are the same, it's probably not right. But what if those numbers are almost the same? Is 23 the wrong number? What data validation rule do you write here? I mean, you know how to do all the things about, okay, a date should be a date, and this date should be after that date. We know how to do those kinds of things in form packages. Visual Studio makes that easier and easier to do. But is the data any good even if it meets validation? How do we go from this screen to this screen where we put in numbers that met all the validation criteria, but together when I consider those numbers as a whole, they don't really make sense? So the suggestion here and the opportunity is to use a segmentation algorithm. Okay, and we have one of these. We have it in SQL Server 2000. It's enhanced in 2005. What segmentation is traditionally for is to figure out how to optimize a campaign, for instance. So I've got different sets of customers. I got the sort of dual income, no kids. You ever heard that term, DINKs? That came from this kind of data mining. We noticed in the population a whole bunch of people like characteristics. Both parts of a couple worked. They didn't have children. Some fancy person gave it the name DINKs, but that was a cluster, if you will. Look at this data here. I mean, this is so patently made up data, obviously. And you can kind of see the clusters, right? And you look at that and you say, okay, somebody's in one or the other. But what if they're not? It's interesting when they're not. And if I take those 5 or 6 or whatever data entry fields and I run them against a clustering algorithm on my existing customer base, the software itself can suggest that this data in its whole isn't really right and maybe needs to be looked at. Maybe we don't reject it, but maybe we put it in a pile for manual processing. But it may be, you know, in your customer base that you have a whole lot of highly educated people. And in general, there's a whole bunch of people in the database that have, you know, say 2 years less education than they've been on the earth. How would you know that? How would you ever have written that when you sat down to write that up? So that's my suggestion. If you want to chat about that, I'm happy to chat about that. We've been talking to a couple of ISVs about the concept. We built the data mining gear inside of this release, inside of SQL 2K as well, to be totally embeddable. It's really not an end user tool, it's a developer tool and it's embeddable. So we're going to take a shot at a demo in very few minutes. And then I think we're probably going to have to skip over the management stuff, I'm afraid, because we're kind of right on the bleeding edge here. So we'll do it real quick. Okay, demo, fast,
We'll do very
fast.
quick. So the only demo I want to show you here is a lot of you who use reporting services, you said, geez, I want to take your functionality and embed it in my own app, but not have to have a report server. Maybe I'm an ISV, and I want to embed it in there. So what we're doing in SQL Server 2005 is we're putting out these Visual Studio report controls for both WinForms and web forms. So as a developer, yes, this gentleman loves everything we're showing here. I'll have to give you a prize. What we're doing here is we've got a simple WinForm here. I'm just going to start it up and show you that we've taken our controls from reporting services so you can embed them inside of your app. All you do is pass us the RDL, the report definition that you want us to render, the data set, and we'll go off and we'll actually render it. Well, it's going to take it a while to do this. Instead of I'll show this in the Cabana if people want to see that so that Bill can talk about manageability. But the key thing here is it's all about productivity for you to take advantage of the rich business intelligence features that SQL Server 2005 offers.
I think it's almost there.
It's there. Yeah, no. And if I click run, it will run, and you'll see the report render. So why don't we flip back to the slides? And you can.
One of the key things here is we started the reporting services thing. We shipped this in January. Now we've got the controls coming out. We've got the ad hoc user stuff coming out. We're just going to keep turning the crank on this. All right. I'm going to beg your indulgence for about 3 minutes to try to do the manageability stuff. I've got about 43 people on my team that work on manageability. They're all going to be ticked off at me that I did an entire 3+ years of their effort in 3 minutes. But I'm sorry, guys. That's just the way it's going to be. There's a bunch of cool things. I'm actually unbelievably proud of this team. I don't know if it's unbelievably, but I'm just so proud. I can't describe how proud I am of this team. They have really reinvented the management experience for SQL Server. One of the key things is they have integrated it. We had separate management tools. Dave showed you that stack. There's a lot of components now, notification services, there's broker, there's all kinds of things in the box. It's an integrated management experience, all put in one box, all working with the same kind of gestures and user interface. And that's a really important thing because we are really after trying to make your productivity as DBAs or as end users all that much better. So a lot there. We have scaled down the time and effort for management tasks. We've really spent a lot of time looking at the jobs that you do with our tools and said, you know what, guess what, we clustered them. I mean, we didn't use the data mining algorithm, but we really found that certain things are like, and we built really fast paths to a lot of that stuff. And everything here is scriptable. I mean, it almost makes me cry. We pioneered this kind of graphical user interface to the database, but the real world is that a lot of stuff happens lights out. A lot of stuff happens across thousands and thousands of machines, and scriptability and the ability to run in a command line and things like that are important. So we have done that in this release as well. So a couple key things. What you used to know as Enterprise Manager is now called SQL Server Management Studio. This is the integrated management console for all the components of SQL Server. We are replacing, not replacing, DMO will go on. There will still be backward compatibility with DMO. We have a new object model called SMO. It's managed code, and it's much, much faster. We are seeing installations of companies that have thousands of SQL servers, hundreds and hundreds of thousands of tables, millions of objects in their database. DMO was not up to that level of scale. SMO is, and we've really worked hard on that. We've done something new in the command line because it wouldn't be a good release of SQL Server if we didn't change the name of the command line tool and, in fact, change the tool itself. This one's a real gem. SQL Command is awesome. And if you've got any of that old kind of Unix shell kind of geek in you, you're going to love this tool and what it can do with command line parameters and expansions and things like that. And then, as Dave said, I won't belabor it, a replacement for SQL Mail called SQL iMail. And then finally, two things that have really grown up a lot. I think a lot of folks have come to appreciate these tools. The Index Tuning Wizard has become the database tuning advisor. Time doesn't really allow me to speak to it, but we can speak to it. Mahesh has a talk, and he will probably cover that. And we'll have this in the cabana. And we can also speak about all this stuff on the floor while the pavilion's open. And also XML Show Plan, which is really, we've kind of opened that up so you can get more value out of Show Plan. So sorry for my management team how fast we went through that.
No demo.
No demo. Okay. So we're into overtime if you play soccer or football, as the rest of the world calls it. Do you want me to finish up here? All right. Slides I've never seen before in my life, but that's okay. We're really proud of this release. I mean, we're tremendously proud of this release. And I know you've been waiting a long time for it, and we appreciate your patience. But we have a team of, quite a few hundred people in Building 35 back on campus that is just enormously passionate about database and enormously passionate about you, our customers. And this is really something that we're very, very proud of. We're very anxious to deliver it. I know you're anxious to get it. But we've really gone after this concept of being the data platform. The enterprise management capabilities that are always part and parcel of a good database product or great database product. The developer productivity that we're trying to achieve, really merging the kind of development and database development experience, application development experience together. And then, of course, the BI components as well, which has always been one of the keys of actually extracting a lot of value from the database. So, this is something, like I said, that we're really happy about, really proud about, and we're anxious for you to get your hands on Beta 2. If you have not picked up, there's some little cards downstairs. They look like this. They're at the booth. If you haven't picked one up, you can pick one up. This has the link. Because you're a TechEd, you're eligible to get Beta 2, and this has the information on it. So there's a lot of things you can do in terms of getting more information. We have a bunch of sessions. The hands-on labs are just around the corner from here. We've got them on pretty much everything. All of our team, we sent a lot of people down here to TechEd, and we're all sitting in the cabana at various times of the day, so you can meet us there. And you can't read that because there's too much stuff on it. And you can't read that because I'm going to hit the button really fast. And last thing, thank you for your time. Dave and Tom and I all thank you for your time. And fill out your evals, please.